Ladies and gentlemen, welcome back to Amateur Repair Time. Now, if you couldn't tell by our last few videos that we uploaded here on the channel, those were videos from an old project that I've had sitting around for about a year, maybe a little longer even. That is this Majestic Grigsby Grigsby Grunow Majestic radio. And I've had this thing sitting around for a while. We worked through it and did a lot of work on it, and I uploaded those videos to our other channel a while back, but I never finished the project, and I hate doing that. I've got a few things that I've done that on through the years, and I hate not being able to upload a finished video instead of just unfinished project videos. So I like filming everything in advance and then releasing it all at once if it's a multi-part series, which is why I re-uploaded all of those. So because I wanted to do them in order, because I intend on repairing this, finally finishing it. It's pretty close actually. And if you have seen those videos and you're seeing this one now, then it must mean that we actually finally finished it. So if you didn't see those videos, basically, whenever I got this thing, I bought it at an auction. I couldn't resist because it was a wounded puppy. One of the stretchers down there on the bottom was broken, was actually missing. That one, you can tell it's slightly different color. I think if I put some clear on that, some varathane on that, it will blend in better. But so we did one video where we repaired the cabinet, cut a new stretcher, put that thing back together, and it's nice and solid, and that got the cabinet where it needed to be. Then we did a second video where we worked through this thing a little bit, and it just had some rotten wires in it that we replaced, and it was just kind of complex. There's a lot of stuff going on. And then we did another video where we had to replace some of the capacitors. There were metal can capacitors like this one mounted to the side here, and they had done some hack job stuff where they put some stuff in parallel to it and all this stuff. We removed all of that and put in new capacitors and went through all kinds of, that didn't look good. That looks like it's coming loose. Went through all kinds of trouble to make sure that the stuff went to where it was supposed to go, and checked it all out. So I think we've got the capacitors right, except for that ground looks like it's not right. So we need to mess with that, obviously. And we need to check the resistors. We need to check the tubes. And then we need to bring it up slow and see if the thing works. I think it will. It's a very well-built chassis. Just really nice. So I think the first thing I'll do is repair that solder joint there on the ground, and then I'll get the schematics out. I wonder if this is then right here. I think I see them. I had them right here the whole time. So all those other videos you watched, the schematics were never far away. So we're going to go through. There is actually like a physical schematic where it kind of shows you, I guess that's what you would call it, where it kind of shows you the wiring, how everything wires up, but only on this side. So the previous video was us working through trying to figure out what the crap was going on this side, but we got it. So this shows us the resistors, how everything's supposed to be routed. We haven't done the filter caps yet, which are over here. They're actually underneath this. So the wiring comes up to this, these terminals. So what I'm going to do is I'm going to take the wire from the capacitor loose and tie it off, tuck it underneath so it's no longer connected, but it'll still be mounted. There are these huge metal cans on this. This is a very early radio, so it's just way over designed. I'm going to leave the wires just in case somebody wants to go back or stuff the cans or whatever in the future. I'm not going to do that. I don't care anything about that. And then I'm just going to simply mount the capacitors, the filter capacitors, to these terminal strips. And I think that will work just fine. Some people said that you can't do that, it'll introduce noise. I don't think it'll be a problem, but we'll see. What do I know? So we got to do that. We got to check the resistors. We got to check the tubes. We got to fix the ground and check that one. And we'll go from there. All right, I got that tacked on there much better. These things, you've got to heat that up really good to get it good enough that the solder is going to stick. So I have to use this thing. This is like a very high wattage iron. I got this at an auction. American Beauty. What's it say? American Electrical Heater Company. It's a 100-watt iron. Detroit. They still make these. So get you one. All right, so that has got that on there good. It's not going to pop loose now. Should I tempt fate? Oh, it's on there real good. It ain't going nowhere. And that one too. But I don't want to keep messing with them. I mean, eventually you can rip anything off. But I feel confident that that's fine. All right, so next thing I'm going to do is I'm going to follow the schematics and check out the resistors so that I can go ahead and order them if I need to order any of them. So we'll just see. If they're close to spec, I'm going to give it like 20%. These are from the 1920s. You know, this is an old radio, so I'm going to give it like 20%. It's 100 years old. If it's within 20%, that's probably as good as it was back then. We'll roll with it. If not, I'll order it. But the main problem I have is that, like, if that resistor isn't any good, I'm not going to get anything that nice. The new stuff's junk compared to that. But, you know, we got to be somewhere near tolerance, I guess. So we'll just measure them and see what we got, and we'll write it down, and then we'll decide. Okay, so I've been going through testing everything, and I think we're pretty good. It was a little confusing. Like I said, this is a schematic of that. It's upside down, though. But it actually is drawn almost identical to how that is. So it's like an actual physical schematic. So it shows you where everything is. We just happen to have the radio sitting upside down. So you can go through and test some of them that way. So for instance, this is supposed to be 4,875 ohms. I've got 4,900. This is supposed to be 5,230. I've got 6,110. That is almost 20%, like I mentioned. But I'll show you here in a minute. This one was supposed to be 3,340. It's 3,450. Very close. 7,900. It's 7,200. Little low. But it connects to the volume control, which is supposed to be 1260, but it's 1,500, which kind of makes up for that a little bit. So anyway, it just goes on and on. There's a couple resistors mounted on the bottom of the thing that are actually right here. They're big, and they're like big coils of wire, basically. They're kind of like this. Very high, over-designed stuff, because it's all early stuff. It was back whenever they were, first using some of this stuff. And then there's one in here. That one's not on the schematics. That's for the antenna. That's just where the antenna connects. So that's this wire. And so instead of just being connected directly to ground, it's connected through a 52 ohm resistor. Must be some reason. Local distance switch, open for distance, closed for local. Interesting. So basically, if you close that, you would be connecting this switch to ground. But they have set it up where you are connecting it to ground through a 52 ohm resistor. And a lot of these coils here, I wasn't able to check. I was hoping to get values of all of them. I was able to check one. I got 8.9 ohms across it, but I don't even know which one it is. We kind of went through this on the previous video, but these things it's just an incredible design. They have this big can on them, and then there's a big old freaking coil in there. And they all look perfect because they've been covered by that can for for 100 years. So, you know, I assume they're fine, but some of them have wiring coming out. So a couple of the wires I was able to check, but the way those things are wound, there's one winding that's, you know, connected through the audio signal or whatever, and then it couples with this other winding that connects to ground. And so you can't really test all that, you know. It's kind of like the IF transformers on the more modern stuff. But going through, this is what I ended up with. So going by this, I got the numbers that I got, and I was able to write them in here. So one was 154, it was at 155, it was almost perfect. The volume control was 1260, but it's measuring 1.5. But one end only connects to this. This is a little high, this is low, so, you know, hopefully that works out just fine. This one, 3340, is 3450. This one, 5230, it's 6110, so it's almost 20% off. We're going to roll with it, though. This one, 4875, it was 4900. And then I ran into an issue where, how do I get the other three values? Because they're not here. They're in a weird spot. They're actually buried, they're potted in one of the cans up on the top. So one of the cans is right here on the top. I don't know if I've showed you that in this video yet. Look at these. It almost looks military just because it's so old. Look at these. So this has resistors in it, and this one has caps in it. It's just how they designed it. And so it shows the wiring on this schematic. So like that resistor, like this line right here, I know from the other schematic, runs into a resistor, and that's it down in there. So these are resistors, and these are capacitors. So I was trying to figure out how in the world could I check those things, and then I figured it out. I have this line right here. It's a green wire, and we know that because they call it out. So there is a line that connects to this resistor, and it connects to the C capacitor. So we've got A, B, and C, which are our filter capacitors. And it actually mentions what they are. Well, it does down here. They're all 2 microfarad capacitors, A, B, and C. It would be slightly different if it was, if the cycle was different. And then it shows them on this physical schematic. This is that can I was just showing you. And so it is showing you that there is a green wire for one of the caps that's right here, and it connects to that resistor. So that resistor, that connection is right there. And then it's showing you that there is a blue wire coming out of the capacitor one that connects to this lug. That lug is right there. And then it's showing you that there is a red wire coming out of here that connects to that lug. So that lug is right there. So really, we have all of our connections here. So if I measure from here to here, we are measuring from here to here. So we're effectively measuring across that resistor inside the can. And it checks out because it's 1550 and it measures 1544. So dead on the money. And then if we measure the other two, we're measuring from here to here, we get 181 ohms. And then the hardest one was this last one. So, but we know where this is. And then we know that this is one of the filament lines on the G80 socket. So the G80 socket is here. These are the filament lines. So by measuring from here to here, we get our last measurement. And they all line up, so it makes sense. 190, or does that say 180 actually? I think that says 180. So 180 and we got 181, 190 and we got 186. So we're all, it's pretty close. There's a little bit going on. There's not much I can do about it anyway because it's inside the can, right? Well, I guess that one isn't this one, but we're going to roll with it. Okay, so then the transformer, I was able to check the secondary on the transformer. I couldn't check this. We're going to have to eyeball that a little bit whenever we get ready to do it. I could check these three, but I couldn't find that lug. I got to, whenever we go to put on the new power cord, we'll figure that out. I thought it would just be right there, but it is not. Yeah, so I don't know. Well, I think that might actually be the fuse. We'll figure it out. So I checked the secondaries. So we got 354 ohms on this winding going into the G80 socket. And then we've got these three different windings that are all filaments. So this is a filament winding. It's 0.2 ohms, almost a dead short, but I think that's how they do that. I have on my pinball machines, usually I don't have to check the actual transformer, so I'm not sure what it would measure on a pinball machine. But we've got 0.2 ohms on this, which is the winding for the G80, and then it starts running the B+. And then we've got 0.1 on this, which is the filament winding for pretty much everything, including the pilot lamp. So the pilot lamp, 3.2 volts. And then it's also running the filaments for all of the tubes, with the exception of the output tube. The output tube gets its own winding. And these are really low. It's like 0.1 ohm, 0.1 ohm. Only reason I think that we're fine, and the tubes aren't installed, well, actually, some of them are. That would explain it, actually. The only reason that I'm not concerned is because I don't really believe that three different ones would short. So they must they measure really low. It must be... I'm thinking through it. I think your problem would probably usually be that the winding goes open and that you lose the winding instead of it being shorted like that. And it's just hard for me to believe that three separate ones shorted. So it's probably, that's just how it needs to be to create those filament voltages. So all that to say, I think we're good. We need to do the filter caps, and we need to check the tubes. So these are the only caps I haven't replaced, I believe, other than these inside this choke. So there's a couple caps here, and there's a 1 meg resistor and a 35K resistor. That's those two there. So those two cans, I believe, are these and the choke. I think we got all the other capacitors. Ooh, well, maybe not. Those are going to be up on the top. Basically, this big old tuning capacitor up on the top, there's a big can there that's inside of that. So I wonder if those are film or what those are. I hate to take that whole thing apart, but we might. Maybe we'll bring it up slow and see. These, you know, these are all across like audio stages. So if that shorts, is it the end of the world? Is it going to burn something up? I'm not so sure. So maybe we try it and just see what's going on. But yeah, that's our last ones, is these little things. Oh, you know what? Don't we know that? No, we don't know. I was about to say, don't we know that those are film because of their size? They're not small enough that we know that they're ceramic or film or whatever. We don't know anything. Okay, so next up, we're going to do our filter caps. And like I said, the way I'm going to do it is I'm going to find the lines coming out of the bottom, which are green, blue, and red. There's just one wire coming out of each. And we've got our ground right here is this black. So ground is connected here. One of the filters is here. So from here to here is a filter cap. One of the filters is here. So from here to here is a filter cap. And one of them is here. So from here to here is a filter cap. So I think that's all completely doable. That one there, just for physical reasons, I might try to mount this something easier if there's a ground right there that I can grab. So that's my plan. I'm just going to cut those 3 wires loose, take them loose from their junctions, tape them up and roll them up underneath the thing so that they're still there if somebody wants to try to restore that can at some point. And we're just simply going to mount electrolytic caps directly to these lugs. Easy peasy. Okay, so next up, we're just going to clean it up a little bit. This thing is very heavy, as you can imagine. If you didn't see the first video where we repaired the stretcher on the bottom, the weight just basically did it. This, if I was just guesstimating 60 pounds, something like that, maybe even more. I mean, it's freaking heavy. And you can tell just by looking at it, obviously. So, I think, I don't know which is which, but, you know, you've got capacitors and resistors and stuff in these big boxes, so we're not going to mess with them at all. But then you've got this little piece. We looked at this in a previous video where there are 4 tubes under here. So I think what I'll do is we will clean all of this, just get it cleaned up, and we'll test these tubes. I also want to get, if I can, inside this to look at what the tuning capacitor looks like, and see if we can find those little caps that apparently are in there somewhere, and just see what they look like. And then I'm just going to wipe it down to get all of the dust bunnies off of it. It's actually in very nice shape for, you know, all things considered. There's really no damage to it or anything. It still looks like it's got the original paint or coating or whatever that is on it. Someone was telling me in a previous video, if it's yellow, don't touch it. So, yeah, I just want to get this all cleaned up. You see all the dust in there. And we looked at this on a previous video. We went under there. That's potted, so there's nothing in there that we can mess with. But it looks like this will come off. I don't know if I'm gonna have to remove this though. It looks like just the top will come off. Maybe. I'll mess with it. Let's see if I can get into it. But I'm gonna leave these in the position that they're in, so that when we test them, if we get one that's bad, maybe that'll tell us something about what's going on inside of it. Okay, I got in there, so I had to take the 2 wires off of the, what do you want to call that? Indicator light? Dial light? Look at the construction of this thing. Just look how well made this is. So there's this tin, well, it's not tin, this steel, I guess, cover that goes over it. And just look how they stamped an oval in it. They didn't stamp lines in it. No, they stamped an oval in it just so that it, you know. I don't know why they would go through the trouble to make it that nice, but they did. You know, I guess they didn't want that to bend, so they put a crease in it. But they didn't put just lines in it or a square in it. No, they put an oval in it, right? And then up here, there are just a couple lines. And there's just, you know, it's just so well made. Just beautiful construction. Same thing here. All right, so I just got inside of this thing. Let me move this out of the way. Let's see if we can tell what's going on. So there's a 5-gang tuning capacitor. Why, thank you. Wonder what that went to. I wonder if it was one of these and they dropped it in there from the factory. No, it goes right there, doesn't it? Yep. I'm sorry, Mr. Factory Workers. I was just kidding. I didn't think you'd actually done that. So my theory was there. You know, I try to come up with my theories. A lot of times they're nonsense, but I was thinking maybe they'd lost one in there and went, and just grabbed another one out of the box to put it on there. But no, that's not what happened. All right, so I found my missing part. Boy, isn't that great. So what do we have down here? There's another one. So that's just an adjustment probably, right? So it looks like all of these can be tuned with that adjustment. I'm not going to tune any of them unless it tells me to in the manual. Which, knowing them, it very well may. I don't see any caps. Oh, you know what? They're caps, aren't they? Is that what's going on? Those are the actual caps? I mean, they're tuning capacitors. Yeah, maybe that's it. Maybe. And then some part of it is connected to ground. Yeah, is that what's going on? These are the capacitors, you know, because as you tune it, it changes the value of them. I don't know. I don't see any capacitors in there though that are, you know, something that you could change or anything. Look at the beef on the plates. Look at this one too. It's out of place. I'm not touching it. See how it's bent? Will not be touching that. I mean, I'll touch it, but I'm not going to bend it back. Maybe it's supposed to be like that. Just look at the thickness of the plates. I mean, look at that. This thing is built literally like a tank. I mean, it's literally built like a tank. It looks like a tank. I can't decide if they've painted it or if it was painted at the factory. I mean, obviously this was under that cover. It almost looks like the entire outside's been painted with something else. But it could just be that that's how it wears. I don't know. I almost think that it's like some kind of anti-corrosive, you know, coating or something. I don't know. So this little cover we're going to take off after we clean it up a little bit more because we need to change the voltage jumper plug. All right, so I'm just going to clean this up, and then I'm going to look on the schematics and see if I can make head or tails over whether maybe that's our 5 caps. Because remember, we have those 5 jars underneath it too. All right, so I tried to get all the dust that I could out of there and wiped it down a little bit. Everything's in very nice shape. And if you look at the schematics, those are not the caps we're talking about. These are the condensers, they're calling them. And they show them right here, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And it even shows that the first 4 have an adjustment, which is this little thing here. And the 5th one doesn't. And then it shows you, however, that after that, there's one for the antenna, which is this one. So it all, you know, but these aren't that, I don't think these are that important, but it would be interesting to know where they are, right? So there's one cap there, one cap there, and one cap there. And I'd like to find them. So they're under, there's one under the last 2 somewhere. And there is one under, there's 3 of them somewhere. I don't know where they're at. They must be on the bottom inside those cans somehow. All right, so I'm going to put this back together, and we're going to test the tubes. And then whenever we get back down to the bottom, we'll see if we can ever find them. I'm also, of course, I have to replace the wire, so we've got that left. So what we've got left is we've got to change the voltage thing, we've got to test the tubes, and we've got to replace the power wire and see if we can find those 3 caps. All right, so I can't test the tubes. I have about 6 tube testers, but none of them seem to want to test the really old tubes. This particular one, which is an ICO 625, actually has the sockets for it. I think I've got a couple other ones that have the sockets for it too. Those sockets are the tubes that we're messing with, but in particular, this 5-pin one here. But I don't have any, I don't know how to set it up. It could be that you just set up the filament voltage and get that right, and then the other part doesn't matter, but I wouldn't think that's true. The gentleman I got this from had a bunch of the older tubes in the side here that I guess maybe he was using this one for those older tubes, but it doesn't say on my reel here how to test them. The very early tubes just had numbers. So we only have 3 types of tubes here. We have G24, and I don't think the G is important. I think it's just 24. So 24, 45, and an 80, which is probably a rectifier. So I've only got 3 types of tubes, but I don't know how to set it up. So without something telling me how to do it, I'm not going to screw around with it. I might fry it. So we'll just have to do it the old school way and just see if it works. And if it works, we'll leave it like that. And I can substitute in other tubes and stuff. I've got a whole bunch of extra tubes. I've got tons. I don't know how many 24s, 45s, and 80s I've got, but I wouldn't be surprised if I've got several of each. I've got a bunch of those early ones. So we're not going to test that. I think the one other thing I am going to test is I want to test, and I may have already done it, but I want to test the speaker coil to at least see if it's blown. So I believe I can do that by checking resistance from here to here and here to here on the plug. So the 2 outside pins and the 2 inside pins, I should get resistance, and I should be able to write that down. All right, well, so from here to here, which is this winding, we've got 392 ohms, which seems right to me. From here to here, which is this winding, I've got 6.6K ohms. That seems high as crap, but I don't know. You know, I'm not used to a speaker this old, so maybe that's correct. But yeah, that's a little scary. I do have a connection from here to here and from here to here as well. So that's measuring out. Yeah, so I guess we'll see. And it's all coming back to me, folks, on these tubes. I must have looked at them in the earlier video. You know more than me because I filmed those videos so long ago, but I just re-uploaded them. So this must have been the one that was in it. It's a Majestic G80. And it has something broken off of it. So that one's seen better days. So I have found a couple more, apparently, at some point. So I've got an RCA here and a new National Union Electric. So we'll put one of those in. So this one isn't going to do much for us. All right. We need to put a new line cord on it. And I think that's about as far as we could go. We'll have to just bring it up after that. Okay, folks, so this is how I did the caps. Easy peasy. So I just taped these wires off in case somebody wants to go back in the future, but that can is completely disconnected. We could actually unbolt it and take it off the chassis if we wanted to, but so one of the wires was coming here. This is ground. So from ground to here was one cap. From ground to here was another cap. And that's not touching. It's not even close to touching. And then this one we had to fly a little bit. So from here to ground is another cap. And they're all 2.2 microfarad capacitors. So that's good. Took care of that. So the electrical cord comes in through here. And it has a knot tied in it. And then one lead goes over to here, which is up to the switch. And then one lead goes here, which is actually the fused side. Typical, you know. I've heard that the reason that they switched the neutral instead of switching the hot, and this is a transformer set, so it doesn't really matter, but I've heard that the reason that they switched the neutral instead of the hot is because it they thought there would be like a popping noise or something when you turned it on or off if they didn't. So, whatever. But I like leaving the stuff the way it originally was to the best that I can, you know. Now, I believe, though, that our switch isn't working. So I'm going to mess with that, and then we're about ready to fire it up. I can't think of anything else to do on it. I considered, instead of flying this line over to the ground, I considered mounting it up here. Electrically, that spot right there, that is that green wire coming over. So that spot right there is the same as this spot right here. And then you could put the cap right here and put the ground right where they're putting the ground for that choke or whatever that is. But nah, I thought this was a little cleaner than that. Okay, so I've got the caps done. Let me see if I can figure out what's going on with the on-off switch. Oh, I didn't show you the cord. So it's a new cord. I believe it's actually made in the USA too, isn't it? I hope so. And it's pretty much identical to the original cord, which I guess that was the reason they do it, right? And I gotta say, the original cord, it's all frayed and everything, but it is pretty quality. This was the part that was inside the set. Well, this is the part that was inside the set. And it's in really nice shape, actually. So it would have been fine. It was just once it got out of the set a little bit, it started deteriorating. So, you know, really, that's the owner. They kept it in a bad place for 100 years. And this is the original plug. I cleaned it up a little bit. You know, there's not much to them. And I replaced the little cardboard thing that was missing. And so it'll have its original plug at least, if it doesn't catch on fire when we start. Look, folks, it's going to be fine. I don't know what you're so worried about. Yeah, so I think we're ready to figure out the on-off switch. If I can't figure it out, I'll just jumper it for now, and we'll try to fire it up. This video is getting long, though, so we're not going to go deep into it, but you can at least see if it's trying to cooperate. Okay, so this is the power switch. Look at this thing. Okay, Now look at this side of it. This is on the top. Underwriter laboratory inspected. It's a 1 amp switch. Under 25 volt, and then on the bottom, made in the USA. All right, are you ready to see the most amazing design you've ever seen? I don't know that I can hold it good enough to do it. Okay, so that's off. And that's on. It swings this spring-loaded thing from one side to the other. Look at that. That's awesome. So that's on. I can't hardly do it where you can see it with one hand. Well, you get the point. Whenever you turn it, it throws that thing back the other way. It's all spring-loaded. All right, so I guess it's just dirty. I'm just going to spray contact cleaner all over it, and spray contact cleaner all over that, and I think it'll work. It's just having a little attitude. All right, folks. This, to be honest, this is the most frightened for smoke I've been on anything I've fixed radio-wise. This thing is so old and so kind of out of the realm of what I understand that I don't really believe that it's going to come up. By the way, I did plug the speaker in. That's a good way to fry it. Leave that unplugged. Okay, so I got the switch working, cleaned it out a little bit, and it worked just fine, according to my meter. So what I'm going to do is I'm just going to bring it up on the Veritran, mine is called. And everybody keeps telling me I need a dim bulb tester, dim blah, 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 blah. Dim bulb testers, I don't even get it. I've had 50 people explain it to me. I do not get it. If the thing starts shorting, it's going to turn on the bulb. And then I'm supposed to sit there and decide if the bulb's too damn bright or not. And then I'm supposed to change it to a different wattage bulb and all this. Or you could just put an amp meter on it and see if it starts pulling a bunch of amps. I don't get it. If there's a short, that thing's going to go crazy. And it tells you the same thing. So I don't understand why everybody's so obsessed that I have to use the dim bulb tester if I don't want to use the dim bulb tester. I'm starting to see a lot of arrogance in some of the radio repair guys. I'm not a fan of arrogance. Never have been. Okay, so here we go. What do you think? Is it going to do anything? I think it might blow up some caps, but I don't... These caps are crazy. They're 2.2. You know, they're little tiny caps. So, and if you're running the voltage, 400 volts. What do you think? I might have to order some with higher voltage. According to this, 306 is as high as we get. But depending on how this is wired, you may end up with more than that somewhere. But I have nothing to go on other than this. So 275, the detector plate, and then there is one here that's 306 volts. As I understand it, if I was to leave the load off, don't plug that speaker in, that thing might run away and just go really high. And we don't want that. So I've got the speaker plugged in. I tested the resistance on the speaker coil. So I think all that's left is just power it up and see what happens. But if anything bad happens, what I would expect to happen is that one of those caps blows up. And then I'll order some more. Should I be wearing a blast shield? I don't know. We'll see. What can we do here? Okay, so I've got the Veritran on 0 volts. I've got the ammeter on the mid-range. It's got 3 different ranges that it can use, and the this thing, it says it's 105 watts, so that ought to be less than 1 amp fully functional. So I think it's big and scary looking, but I don't think it's all that powerful. It's just an old one, and this is how they looked when they were old. I think it's just super over designed. So that's off, that's on. So we are turned on. So I will slowly turn up the Veritran and we'll see what happens. Now we got rid of all the capacitors except for those 3 that we couldn't find, those little value ones. So we shouldn't really have a short or anything to worry about, but we'll see. So I'm going to slowly turn up the voltage a little bit and just see what happens with this. If it starts pegging, then you know we've got some problems. Oh, she's alive. She's sucking a little juice down. So we're at 50 volts. It would be cool I hear something like I would describe that as like transformer voltage. So we're at 50 volts. I think we can leave it at that for right now, right? I don't see any heater glow on anything. I guess we could check voltages. But if we're only at 50 volts, we probably wouldn't get much yet. Can you hear that though? I mean, there's like that high pitch whine. All right, so we're gonna go up a little bit more. It must not be doing much because, I mean, it's not telling me that it's drawing any amps really, but we are on that medium gauge there. Should I put it over on the lower one? Let me turn the voltage back down. I don't want to swap it while we're... Okay, now we're on the low gauge. Yeah, we got a little bit of action, huh? Okay, we're at 60 volts. We're not trying to reform any caps or anything, you know, we replaced all of them. Okay, we're at 90 volts. We're still at less than half an amp. Got a nice blue blue glow on our rectifier, and we've got glow here. It's a TRF set. I don't know anything about those, so it could be like we've got one bad tube and it's stopping the signal, but I do hear something in the speaker. But I don't think that the volume is affecting it. Let's see if I can get you to hear it. Yeah, I don't know what we're hearing. I don't know if I do hear it in the speaker. I hear something. Okay, and we'll try tuning it just for giggles. Well, it's turning, but without the knob on it, it's really hard to... You know, I don't even have the antenna on it, by the way. But you hear it, right? So she's trying to work. All right, so that is actually about 120. It says 110, but so now we get volume out of our volume knob. So our amp must be working. All right, so we've got no antenna hooked up, and I thought maybe it would just grab something out of the air, especially WBT 1110 is 4 miles from here. It literally, it's like if one of the towers fell over, it hit my house. So, and that signal is so dominant. Usually you can just pick it up on anything, but apparently not with this. But I think we have safely got it back up. I need to test voltages. We need to try to trace the signal through it somehow and see what we can figure out with that. We might just try swapping some tubes in the IF and the RF. We can try aligning it, all that. So we've got a whole bunch of stuff left to do. We'll do that on another video. So I hope you enjoyed it so far. Leave your comments down below, and we'll be back with one more video. Hope you enjoyed it.